Previously on Boring Math Tutor, we were able to find the terms given a formula. One was an explicit formula, one was a recursive. But now we're going to be given the terms and being asked to find a formula. So just by looking at the bottom, it looks like I'm going up by 2 at a time. And that's the type of sequence that we said is an arithmetic. And whenever you have an arithmetic sequence, you could say that the formula for it is an equals whatever the first term is plus the common difference times n minus 1. So in this case, our first term would be a 2. If we're just looking at the bottom, and then the amount we're going up by, well, that's actually 2 as well. And that would be the formula for the bottom. But again, this is just for the bottom. So what I really have to do is say that the real formula that we're looking for, the real an, is going to be 1 over that. So 1 over the formula for the arithmetic. Okay, now let's take a look at the next one, where in this case, it doesn't look like we're just constantly subtracting the same thing each time. But if we ignore the negatives for a second, it looks like what's going on is we're constantly dividing by 4. Now, instead of saying dividing by 4, I could say I'm multiplying by 1 over 4. And when you're constantly multiplying by the same number, that's actually another special type of sequence that's got its own name. It's called a geometric sequence. And just like there was a formula for an arithmetic sequence, there's a formula for a geometric sequence as well. It's that an will equal a1 times whatever the number you're multiplying everything by, that's called r, or ratio, or common ratio, raised to the n minus 1. So in our case, it's going to be 4 times, and now this is key, we're not really multiplying by 1/4, we're actually always multiplying by negative 1/4. That's a little bit strange, but we should say that the real common ratio is actually negative 1/4, and we're raising that to the n minus 1. So that's it. That's the formula when you're given these terms. This one is actually even easier than even the first one, where it's just an equals a1 plus d times n minus 1. So it's going to be 5 plus, well, how much are we going up by? 3 times n minus 1. That's it. This is a nice, easy one. Moving on to the next one. Okay, does it look like we're adding or subtracting the same thing each time? No. Does it look like maybe we're multiplying by the same thing each time? Well, the first time I'd be multiplying by, oh God, that's a nasty fraction to even come up with. It would be whatever 4/3 divided by 1/2 is, and it's like, is that really going to work for each one? Well, turns out no. And what we can do is instead take a look at what other pattern we see. Well, on the bottom, it looks like we're always going up by 1 each time. Okay. So that's an arithmetic on the bottom. So if I just wanted to give a formula for the bottom, I could easily do so. It would be 2 plus, well, how much we're going up by, which is 1 times n minus 1. Now, up top, though, is there anything special about these numbers? Well, actually, 4 is 2 squared. 9 is 3 squared. Oh man, these are the perfect squares. So the formula for up top could just be n squared. But we got to remember that there's also these negatives. And these negatives are coming as they're alternating. It's going from positive to negative to positive to negative. How do we take care of that? Well, turns out we can now introduce a new idea of an alternator. And if I tried taking -1 and raising it to the n, what you're going to see is something kind of interesting. So if n was equal to 1, then you would have -1 to the 1, which is -1. And then if I raise it to the 2, well, I get +1. If I raise it to the 3, I get -1. To the 4, I get positive. So it just keeps alternating between negative and positive. Now, if I use a n up here, I end up starting with a negative. But here I'm not starting with a negative. I'm starting with a positive. So another thing we can do is say, well, we could just put a +1 right next to it. And then that would have changed things where it would have started with a positive. So if there was a +1 here, well, now this actually comes out to, no, it doesn't come out to that. It comes out to 1. If I put a +1 here, then this one comes out to -1. So it would just change what all of these would be. It would alternate between 1, -1, 1, -1. But it would start with a positive. So in this case, we do want to put the +1. So that way it starts with a positive. Because if you plug in that 1, well, you get -1 to the 2, which comes out to +1. So that's what we want. And now if you are not convinced that this is the right formula, you can try plugging in 1. And you would see that -1, 1 + 1 times 1 squared over 2 + 1 times 1 minus 1. And you would see that this is actually going to come out to that first term of 1/2. If you tried plugging in 2, you could convince yourself that it's going to come out to that. But anyway, we're going to see this idea of an alternator, -1 to the n, -1 to the n + 1. It's going to show up a lot as we get into series, and that's coming up soon. All right, that wraps up video number 2 in our sequences and series playlists.